Hi friends, today we are going to discuss concept of dimensionality reduction techniques PCA versus LDA. So what are these techniques we will discuss in detail. Okay, next first of all coming to the PCA. What is PCA? PCA means principal component analysis. So what is this exactly PCA means? It's a mathematical procedure with simple matrix operations from linear algebra and statistics to transform a number of correlated variables into smaller number of uncorrelated called principal components. So from the using the mathematical procedures, what we will do, the number of correlated variables will make it as a small number of uncorrelated. So what they will call? They will be called with principal components. So to make data easy to explore and visualize. So from the diagram, you can notice that. So it is easy to explore and visualize also. Okay, right. This is PCA. So what is the goals of PCA? What are the goals of PCA? So to identify hidden patterns in data set. So it is very much useful in identifying the hidden patterns in the data set. And next one is to reduce the dimensionality of the data by removing the noise and redundancy in the data. So what it will do? It will reduce the dimensionality in the data. So with what? By removing the noise and redundancy. And next thing is to identify correlated variables also. This is also the goal of PCA. Next. So it's a continuation of principal component analysis. What is this? PCA method is particularly useful when variables within their dataset are highly correlated. So correlation indicates that there is redundancy in the dataset. So PCA can be used to reduce the original variables into a small number of new variables, which are called principal components. This is important. Principal components. Explaining most of the variance in the original variables. So if you notice the diagram here, you will get the idea how this is working. Okay, see from the diagram. So PC1, PC2, how they are changing the dimension. Based on that, we will get the principal components of the related variables or the features. In this way, the principal component analysis will work. Next, what are the applications of PCA? So most commonly used dimensionality reduction technique in domains like facial recognitions, computer visions, and etc. And one more is used in finding the patterns in the data of high dimension, like in the field of finance, data mining, and etc. These are the some applications of PCA where we will use PCA most. And coming to the LDA. So what is mean by LDA? So LDA means Linear Discriminant Analysis. So what is this LDA? So the objective of LDA is to perform same thing. Like PCA, it is also used for dimensionality reduction only. Okay. However, we want to preserve as much of the class discriminant information as possible. So we need to preserve the information. And LDA help us to find the boundaries around the clusters of the classes. Okay, so we have some, it helps to find the boundaries around the clusters. Okay, it projects data points on a line so that your clusters are as separated as possible, with each cluster is having the relative distance to the centroid. So it will make the clusters, in between the clusters, as much as possible, they will be separated. The distance is very high, maximum. And it is a supervised algorithm only, as it takes the class label into the consideration. Yes, it consists of labeled data only. Okay, so continuation to the LDA. So it determines a new dimension, which is nothing but an axis which should satisfy two criteria. What is the first criteria they have mentioned? Here, maximize the distance between the centroids of each class. See, before LDA, but this is after LDA. We are going to get the axis. So where we can separate these two things, clusters, classes, or minimize the variance with in each category, and two things. So maximize the distance and minimize the variance. So this is the main concept of LDA. Then, yes, what is the difference between PCA versus LDA. So PCA and LDA both are linear transformation techniques only. But LDA is supervised, whereas PCA is unsupervised. So PCA ignores class labels, whereas LDA takes the class labels. Okay. And PCA performs better in case where number of samples per class is less. So if you are having less number of classes, it is better to take the PCA. But whereas LDA works better with large data sets having multiple classes. That means if we are having more than two classes, it is better to take the LDA. Why? Class separability is the important factor while reducing the dimensionality. That's why. Okay. And PCA does more feature classification, whereas LDA does data classification. So both are different. It does the feature classification, it does the data classification. So PCA will take the features, LDA takes the data classification. And in PCA, the shape and location of the original data sets changes when transformed to the different spaces. Okay, so definitely the space and location will change. We are taking the principal component, so it will change. But LDA does not change the location, but only tries to provide more class separabilities. It will try to separate the classes more with maximum distance and draw a decision region between the given classes. So this is the difference, the main difference or comparison between the PCA and LDA. And from the diagram also, we can notice that. So this is PCA, component access that maximizes the variance. If you notice here, we will get the idea how it is working. So it maximizes the variance. And whereas LDA, maximizing the component access for class separation. See, these are two classes. So distance is separated by access and distance should be maximum. Distance between these two clusters is maximum. And we need to get the minimum variance. When you drop here, you will get the minimum variance here. So minimum variance. So usually this is the main difference between the PCA and LD. Okay, this is end of dimensionality reduction techniques, both PCA versus LDA. Thank you.